everyone, and welcome back to PyLadies Con. It is a joy to introduce our next speaker, Dr. Bonny P. mcclain. Dr. mcclain is a best-selling author, geospatial data analyst, and social anthropologist who uses advanced data analytics and Python to explore how place, poverty, race, and gender intersect in people's lives. Her talk, Decoding Climate Science with Python and Open Data Resources, What AI's Energy Needs Mean for Our Planet, will uncover the haunting destructive harm of artificial intelligence that is often overlooked as we rapidly integrate AI into our daily lives. Please give a round of applause as we welcome Dr. Bonny mcclain to the stage.
The best way to learn 3D geospatial data integrated with Python is to get an example, see if you can work through it yourself. And this is behind a paywall over on Medium, but the idea is easy to replicate. You pull in a bunch of 3D data and we write some code so that we can visualize it in a Jupyter Notebook or in Visual Studio. It's just like 3D capture, right? So you find information, you process it, you clean it, and then you can represent it and look at it in another format. And that's what we're going to do. We're going to look at 3D point clouds, we're going to look at shape files, vector, raster, all of these types of data. And it may be the first time you've seen this sort of integration with Python. And this is a great one because we have DM data, we have point cloud data, there's a whole bunch of data here, and it's a Netherlands data set where we have the point cloud. You can get your raster files here, there's TIFF files, there's photograph, there's a whole bunch of different data types just in this one geotile resource alone. We also have USGS data, and as you can see here in Earth Explorer, because of the government shutdown, I just kind of expedite it through like how you can get satellite data here. You find your area. I picked Phoenix, Arizona, because we're going to be zooming in on that a little bit. Shape files we can get from OpenStreetMap extracts here. You just zoom your little hover around, and you'll see like where in the world the data might come from. You grab the data. You download it. You have a PBF file and shape files. The shape files kind of work a little better, but I wanted to show you the different types of data that you can get. And this is the data that we see in OpenStreetMap, right? We have buildings, land use, natural resources, places of worship, roads, traffic, transport, all those different types of shape files that we can layer on to other data. And this data here, this is from that Medium article. I'd like to work in Visual Studio. So you just import it. I create like a environment over in Terminal, and then I can activate it over here in my notebook. And then I have all this data here. So you got to get your libraries uploaded. NumPy, Matplotlib, these are ones that are probably familiar to you. But then like the Open3D and the LastPy. And pandas. These are types of data that will allow us to visualize things in 3 dimensions. And you can see that LAS file I was telling you about that I got out of the Netherlands database. You know, I am reading that file in. If you look on the left, those are all the files I've already uploaded, different files, not just necessarily for this project, but I load them in so that I can access them. And we're getting information about our data here. We need to know what the column headings are. We need to know a little bit about it. We can set how we want the data to look. This is a lot of Python code that maybe you're familiar with or not familiar with, but when you're generating the data, it's going to show you a visualization. When you see that visualization, you need to close that window or your code will stop running. And I'm just pausing so you can get a little feel for what some of the information is here. And, we're looking at, I just randomly picked one of those little grids in the Netherlands. I'm not even really sure what we're looking at, but you can see how the data can be rendered right in your notebook. I'm looking at the TIFF file. I'm pulling that in. I'm looking at all the other different files. I love this one too because you can build that zoom function right in. And you can substitute your own types of data. I'm showing you the data extensions. You can substitute these types of data into here and look at your own data. I was just using the resource that was provided, only because this video is going to be long over and you need to have something that you can go back to again and again if you want to recreate this. And now we're going to put, that's the zoomed in that you're looking at now. Now we're going to look at some of the shape files and pull those into the notebook as well. I picked some of the roads in the area, and you can see here the data plot of roads. Here we can find out, what's the CRS. We're getting a little more information about the data. We can just plot, we can just plot the information that we're looking at right here. We can change the colors. You have a lot of maneuverability. This is a very interesting way of looking at the data too. This is pretty high resolution. And this is just running it in your open data. Other types of data that we're pulling in, we have the rasters. So, we have drone imagery. We're looking at pulling in another type. I was getting an error here, but it was rendering. This is a shape cloud and point cloud visualization. And this is just the different types of data that I pulled in to look at, because now we can zoom in and see this at great detail. Now you can see the green in this, showing the little marked roads and things that we indicated. We can also look at where this layer is in terms of, we blend them together. And that's just an example of rendering 3D data and learning a little bit about the packages in the libraries. This is the environment. I created a minimal DS environment so that it's not full on Anaconda. It's been edited a little bit. We'll show you that also so you can see. And this is more the National Water Information System. Show the USGS. We have a lot of data in there. Here you can see the zoomed in little tile, and you can go in, you can see the buildings. I was using this for a groundwater project I was working on. So you can zoom in, you can zoom out. You can get data just by clicking on the data that's offered here. There's a site number, site name, what type of data it is. What type of well it is. And this is like Blender. This is kind of how you can easily visualize some of this 3D data that you generate. We have a way of pulling this into Blender, it's open source. So it'll always be free. So you go in and you can play around with it. It does have a little bit of setup involved, but you can pull in your 3D Google Earth tiles. You can pull in OpenStreetMap. You have a lot of different types of data sets that can be pulled in for evaluation. And you can just do like 2D layers. You can do CSV files, shape files. You can you'll see examples of where we layer all that in. This is a QGIS rendering of buildings next to a mining environment. And this is what I was talking about with Anaconda. When you want to set up your environment in your terminal and you want to do Miniconda and Conda Forge, if you just do a Google search for this title, this is about 6 years ago. This is who I learned Python from. And he just has a nice streamlined way of looking at the data and setting up your environment, which I think is really, really important, especially when you want to hop in and explore. I keep all my environments specific for a project. And then if I don't need it anymore, I can delete it. But these environments are created using the types of packages that are compatible. Like I had to add in this version and I had to go back to Python 3.10 just to make sure everything was going to work because I was doing it kind of quickly. But, sometimes it does work with the later versions of Python, but I didn't want to have that incompatibility. So I just created this environment everything ran kind of, okay. So I left it. And these are some of the environments I've created just for projects that I've done. Here's another project where, I love Blender because Blender has a Python scripting window. It runs on Python. You have to remember, though, it's a different Python than is out there in the wild on your computer. So you have to create your path specifically to this version of Python. But once you get this all set up, you have the console, you can write your code. I believe you can get a little help with your code. I'm not sure where, but someone told me there's like a little, I don't know if it's an AI. Well, obviously it would be AI. I don't know where it is, but I think it's in here somewhere. So here, this is some roads I was looking at in the Democratic Republic of Congo, because this is a signal that you can get of where there could be deforestation. You could see where there might be illegal mining. You can see, or they call it artisanal mining. You can see where these roads are going in. You can see where the deforestation might be occurring. That was the polygon that you saw before this screen. And you can just play around, like what you're looking at on that right where the cursor is right now. A lot of that is that GeoFabrique level data as well, because you can pull in OpenStreetMap directly into Blender. And this is just showing you that window where now we're back focused road network. You can see those buildings, and you can move around and see the extruded values of the building height and the domains. And, this is another project I was working on. I wanted to look at the data centers in Phoenix. I picked Phoenix because there's only like 167 or something of them. And I was hand geocoding these because you have to go through and make sure they actually make sense, because you just saw one that was actually stuck in a road somewhere. But just to show you the volume, this is a future site of a data center. But when you scroll out, there's so many of these. I picked some that just were easily visual. And the reason it's a problem is we have land across the globe that's drying, right? You've probably heard about freshwater being compromised. The subarctic lakes are starting to dry out. But, the problem is really the south, the agriculture, where the groundwater depletion is happening. And this is where a lot of those data centers are showing up. And if you think of groundwater like oil reserves, thousands and thousands of years to get there, and then we're pulling it out in record time. And what's happening is some of these towns and cities like Houston, New York, they're actually sinking because we're pulling the water out from under there. And it's really important to realize that we're making all these demands as well, because these are the same data centers in 2D that we're seeing here. And you can see the limited water, just the waterways that are here is in blue. And then we can actually see what I did is I built out the buildings that are also in that area, because you can see the residential, the commercial demand, agricultural demand, and then put on top of that these data centers that are very thirsty and require a lot of water for cooling and for other things. And we have to be mindful of that and really do a little bit of accounting. This is another Earth data set that was pulled in to the file. It's looking at soil moisture, groundwater storage by percentile. So this is another data set that you can pull into a notebook right here. This is just, I call this groundwater. And you see, what I like about using Colab is I can pull all my files in and just do a really easy like file path and just run everything. This is that link to the data you just saw. I downloaded it and uploaded it here to Colab. I can get a little information about the data. I'm looking to see if you want to see what the CRS is, but you want to bring it in and visualize it. And that's what we want to do. We kind of want to see what that groundwater is telling us. And you can see here vertically that the groundwater, this deep purple area, that what I just circled, that's Phoenix and Chandler. And below that is Tucson. And you'll see it labeled in just a minute, but you can actually look at the groundwater in that area, and we can create more stories from it. I fixed this on another slide, but another part of the video, but you can see right here, Phoenix, Mesa, Chandler, those are areas where we were identifying these data centers. And as you can see, as groundwater storage goes, those are the areas that are most compromised. And that's part of the story. This is showing you where the population growth is predicted to be over the next 10.
Thank you so much, Dr. Bonny P. McClain, for your insightful and inspiring presentation. Your demonstration of integrating 3D geospatial data with Python through practical examples really illuminated how powerful these tools are for visualizing complex datasets. Your emphasis on highlighting real-world issues while exploring different technical geospatial techniques made this talk very captivating. And thank you to everyone for being here. Hopefully you learned something new. Stick around, we have more talks coming your way.